Okay, so we're all here for real-time visibility using the client statement cache to troubleshoot OpenEdge performance issues, right? Everybody's in the right room? Okay, nobody's getting up and rushing out. All right, so we're going to talk about three main things here. What's the user doing at any given moment in time? How do you set up the client statement cache? And what is the impact of using the client statement cache? So there's three distinct topics that we're going to go through here. So we'll start with what is that user doing? Have you ever been happy, you're on your tropical islands, swinging in your hammock, not worrying about anything that's happening in your production database, everything's great? How many people set their usual job description? Cool. So for the rest of you, you've probably spent a lot of time wondering, as you're having problems with your system, what code is running when a user calls up or you notice that you have a session with very high activity. What code is driving that? That's really what you need to know so that you can go back to development and say, hey, this is where you need to make some changes. Or you have a connection that doesn't seem to want to stop for some reason. It's just going and going and going. Or maybe you have some users that are in idle transactions and the BI file is growing and growing and growing. You're wondering, how did they get there? What are they doing? What code is driving this little problem? Maybe you've seen the infamous user XYZ has record ID 123 locked and you can't proceed, and you need to know where is that record lock coming from. It doesn't really help you a lot to try to call the user because they're not going to answer their phone and they don't know what code they're running anyway. Or even just knowing what the typical utilization is with your system. What programs are usually running? What's normal to see within your system? Well, there's this cool feature. It's called the client statement cache. It was introduced in OpenEdge 10.1c, which was in 2008, 16 years ago. So it's been around for a long time. It's a relatively old feature. And what it does is it keeps track of the statement that most recently accessed the database. So it doesn't tell you what a non-database statement might be running is, but most of the things that cause problems are database statements. So those are the ones you typically need to know about. For 4GL clients, you get the procedure name and the line number. It's the debug listing line number, so you have to have debug listings to get to the right line. It's not the source line number, but it's with all the preprocessor stuff expanded. For SQL clients, you get the SQL statement. So if somebody's got to select blah, 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 usually goes on about this long, you get that whole thing. It works for both local and remote clients, so it's not restricted to just shared memory or client-server connections. The results are stored in the database. So you can query them or look them up through Promon or something like that. So you don't have to go find a log file somewhere in some mysterious place that's never anything that you can remember. There are three ways that you can access the data once it's been collected. You can go to Promon, and there's a series of screens that you navigate to. Or you can get it from the VSTs, the virtual system tables, so you can write a 4GL query to go out and fetch the data and present it to you. Or you can use Protop, even the free version has all this kind of stuff in it, where all the VST work has already been done for you. So you don't have to actually figure out how to write that code. So if you're going to use Promon to get the results from the client statement cache, you go to the R&D menu, number 1, option 18, 7, client statement cache. And you have this menu here of all the various ways that you can get it turned on and view the data. But viewing the data is number 7. So you click 7, and you put in the user number, and it tells you, very cleverly, that line 1254 of Dyn Viewer Update in lib/dynscreen.p is what that user is running. That's the last time they talked to the database. That's the line of code that was being executed there. So you immediately know if that person is causing a problem, what they were doing. And then you can call Rob and you can say, Rob, line 1254, what are you doing?
Then I'll say, Tom, what are you doing?
Or you can write some 4GL code with the VSTs, which looks kind of like this. So you got to find out what the connection is. Everybody has a connect record in the VSTs. So you fetch the correct connect record, which is your user number. The user number is the user number reported in the log file when you log in. You add 1 to it because the VSTs are offset by 1. They start at 1 rather than 0, or is it the other way around? They start at 1 rather than 0, yeah. And then basically you loop through connect cache line number and display the stack. So you can either get the top of the stack or you can get the entire call stack that got you down into whatever it is that you're doing, which sometimes it's useful to know what the whole stack was. Usually it's just the top of the stack that people care about. But so you could write some VST code like that to do it yourself. And you get some output that looks like this. A little bit prettier than that Promon screen. Not quite .NET GUI pretty, but still prettier than Promon. Or you can integrate it into a tool like Protop. So what we've done with Protop is we have the active transactions, the active users, and we kind of sort them so that the most active or the longest running transaction is at the top. And then we append the statement cache information over here. So you can see all in one place where the activity is and what it's being driven by in terms of the cause of that activity. So it all correlates quite nicely. And here we have a program that's 118,801 lines long. That might be an issue all by itself. We also generate alerts that include the client statement cache information. So if something's going wrong, now you know not only that it's just an interesting number, but there's something you're being alerted to here. So we're being alerted to blocked sessions. This is the record locking stuff we were talking about. And we can see that the record lock is coming out of line 32,993. There's 2 users that are being blocked by that guy. And so now you go back to the code and you find out, well, why are you holding that record lock? Do you really need to be doing that? Is that correct, or is there a bug here? So to recap, for accessing the CSC, once it's already been turned on, you have this for all supported progress releases and client types. There's no extra licensing involved, and it allows you to zero in specifically on what line of code was being executed by the client at that point in time. That helps you to eliminate a lot of uncertainty about where to look for problems, and it's really easy to use. Everybody convinced? Any questions so far? Okay, great. So now that you have all that information, you can actually swing in your hammock and you can enjoy your day, because now you know that it's easy for you to go back to the programmers and say, this is what you need to fix. Okay, so you're all sold on what a great feature it is. Obviously, the next thing you want to do is you want to know how to set it up, how to enable it, how to make it work for you, right? Everybody wants that. Anybody doesn't want to use the client statement cache? Okay, good. So to configure it, you have some options you got to think about. Do you want the top of the stack, or do you want the whole stack? So that's a question of the current line or all the lines that it took to get there, your whole call frame. Do you want to run it continuously, or do you just want to run it once? So if you only run it once, then you get what's happening right then, or what the next thing to happen is going to be, but then an hour from now you won't have any information. So usually you want to run it continuously. Should you enable it for a few selected clients or for all clients? Well, that really depends a lot on whether or not you have insight into where problems are going to come from. If you know that a certain group of users or a certain type of users are the ones that are causing your problems, then you can narrow your focus and you can just enable it for those specific users. But if you don't know where your problems are going to come from, then you may want to enable it for everybody as a kind of a global thing. Then there's a temporary file directory. So like many things, scratch files have to be created under certain circumstances, and you need to have a place to put those scratch files. By default, the temporary file will go in your working directory, but you can decide that you would like to have it in a kind of a centralized place, much like you do with the capital T parameter for your client client temporary files. Unfortunately, client statement cache does not follow the capital T parameter, so you have to specify it discretely for that particular purpose. There is an inconvenient bug in that you can only change that temp file directory one time per Promon session. After that, it just tells you, yeah, I know, that's where you told me to put it. Yes, no, I won't let you change it. It's here. So, but you can restart Promon and then you'll be able to change it again. So, if you're going to enable CSC with Promon, here's kind of how you go about that. You go into familiar looking screen here. You go to Promon 118.1, Client Database Request Statement Cache, and you activate for selected users or all users. You'll get a list of users, and you put in a user number, and then you select whether you want to do it a single time, for the full stack, or for one time. So over here, I did just once, but usually I'm going to do single is top of stack, one time is the one and done kind of option. It's kind of confusing the way they name those. I'd have gone 0, 1, 2 myself. Or you can script it. So in some cases, we have some customers who like to have the client statement cache enabled for everybody all the time whenever the database is running. So they have a script where you run Promon and you take the input from the you take it from a file, or you can take it from the script itself, and that basically just walks through the Promon scripts, enabling the client statement cache for everyone. You can do this for either Unix or Windows, and so whenever your database starts, you turn it on, and it's all ready to go. It's invaluable for those people. They feel that it's a really important feature for them to have. And then you can view, as we saw earlier, the results in Promon. So once again, Tom is still running line 1254 of dynamic viewer update, whatever that does. Or you can do it with CSCs, or VSTs rather. So VSTs, they're typically read-only. You think of VSTs, the virtual system tables, as read-only tables, but actually there are a few updatable fields. There are a few fields in the VSTs which you can write to in order to enable features like this. So we can update the caching type with connect caching type equals 2, which says I want the full stack in this particular case. Or if we didn't find the connect record, then that user has logged out and they're no longer connected. So I even have a little bit of error handling in here, which is unusual for unusual for a talk at a PUC. We don't usually do much in the way of error handling. And that, whoops, we actually already covered this. So viewing the output with the VSTs is the same code as before. And then ProTop has a couple of screens where you can either enable the client statement cache for a specific user by putting their user number in, or you can do the process ID. So sometimes you're at the operating system level and you can see that a progress session, you have the PID from the process, but you don't know what the user number is, so it's easier to just put the process number in here rather than try to figure out what the user number is. You'd have to go into the log file and you'd have to grep for the process ID, and then you'd have to find the user number from that. Or you can just go through this. And there's a little warning here, some helpful information about how you might want to make your choices. Or you can just enable it globally within Promon. Just push a button and does it for you. ProTop. And then you get output that looks pretty much the same as it did before. There's a reason for that. I copied the slide. And once again, we got some alerts. So it's cool. So you can set it up really easily. You can either use Promon interactively or you can script it. You can roll your own with virtual system tables. You can take that little code I showed you there and you can write your own little thing, or you can use ProTop and kind of have all that hard work done for you. Usually, I recommend that you do top of stack. because that's the quickest, simplest, and it zeroes right in on what you want to know. It's not all that frequent that you really need to know the steps that you took to get to that line. Once you know what the line is, you probably know what's going on and you can fix it pretty easily. If you have a lot of remote clients, so you have a client-server application, Windows clients, Unix backend, then you might want to be a little bit careful about enabling it for everyone all the time, and we'll get into that in the performance side of things. But typically, well, not typically, but if you have one of those applications which is largely a shared memory application, you have a lot of app servers, you've got things that are connecting to the database that way, then you can pretty safely just do an enable all, and you won't have too many issues. So what's the impact? Now that you're all sold on how easy it is to set up and how much fun it's going to be, you're obviously going to be wondering, does this have any performance impact on my system? Or is nobody's worried about that? Okay, I thought so. Oops. So it's a great feature, but obviously there's no free lunch. Everything that's good in life costs you something. So we're going to talk about what that cost is. First of all, there's memory. So in order to enable the client statement cache, you need to consume some memory because the cache itself has to be stored somewhere. At DB startup, you'll have 28 bytes that are allocated per user plus the number of servers plus 2. You'll have some shared memory that's allocated at startup, and this is to make the client statement cache available. This doesn't increase or change because you're turning it on or off. This is just what the memory impact of the feature is. And then when you enable a connection, you use 32 additional bytes of memory plus 256 bytes for the stack, so that's another 288 bytes. So all in, if you have a system with roughly 2,000 connections, you're going to use memory on the order of a megabyte. So this is not a really big footprint feature. You're not using gobs and gobs and gobs of memory. So you can feel good about it from a memory perspective. You don't have to worry that you're going to run out of memory because you've enabled this feature. If you do see this error message here about unable to allocate shared memory, that means that it was not, that the -MXS parameter didn't have enough free memory to put additional users in there. But that, with this kind of a footprint, you're very unlikely to see that. You may see it, and if you do, you need to increase MXS. The other thing that happens is that there's a temporary file that gets created. So if the information that you're requesting exceeds the 256 bytes, then the CST file will be generated. And you get one per connection, and it has this complicated name with the path to the database with tildes replacing slashes or backslashes, then the process ID, the user number, and it ends with .cst. You don't have a startup parameter for the database to control the location. You have to go into Promon and change it there. By default, it's going to be written to the process's current directory. So if your system is set up in a way that you change the directory of the process before the process starts executing, you need to make sure that you have write permission in that directory. Or you need to use the feature to redirect the CST files to some other directory, but you need to have write permission wherever that CST file is being generated. If you change it with Promon, it works for future connections, but for existing connections, it will still try to use the current directory. You can only change it once per Promon session, and after that, Promon will just tell you what the value you set it to is, unless you get out of Promon and go back in. The CST files are written by any self-service or shared memory client and by the remote client or SQL Server process. So those mproserve or SQL Serve 2 processes are the ones that are writing the files. They're the ones who you need to be aware of where the current directory is and whether or not you have permissions. Very, very old OpenEdge releases had some bugs. So, 16, 20 years ago, not everything was quite perfect. Like you had to have write permission, or you might end up holding a latch and then nobody would be able to get anything done. That was kind of inconvenient. The user latch will become very active if CSC is enabled globally. So there's a latch called USR, which is usually used just when you log in and log out. But once you start using client statement cache, it gets used every time that cache gets updated. It does not report on temp tables. So if you're hoping to get information on what's happening with temp tables through the client statement cache, you're going to be disappointed. You won't get that information. Only database tables. And the VST fields cannot be written to on a replication target. So if you're trying to enable CSC on replication, you have to go through Promon. You can't do it with VSTs. And of course, it doesn't really track anything that's not related to the database. The stack itself, if you go for the full stack or the SQL statement, you're limited to 32,000 bytes. Not 32K, 32,000 with zeros. The procedure names that you get from the statement are the procedure names that you gave to a run statement. So they don't expand the pro path for you or anything like that. It's just whatever you said to the run statement. That's what you get for procedure names. As I mentioned, the 4GL line numbers are the debug list line numbers. So you have to compile with the debug list option, like that shows right there, and that'll give you the source that you need to search for whatever the line number is. If you see line -1, that is the cleanup at the end of the procedure. So that's things like releasing buffers that weren't properly scoped and things of that nature. The timestamp on the cached statement, so the cache statement, you get the line number, you get the procedure name, you also get a timestamp, so you know how old that is, which can be interesting if you have a lot of activity. You got a for each that's going through 10 million lines or 10 million records. The timestamp tells you how long it's been doing that. That timestamp will not change even if your 4GL code iterates in a loop and executes the same statement again. So if you have the classic do while true, find first customer, end, you'll only have one statement. The timestamp will never change there, even though you're repeatedly fetching the first customer. And of course, a client cannot successfully monitor itself. That just doesn't make a whole lot of sense. It's kind of like trying to bootstrap your way into space. Doesn't really work. With SQL, because the SQL engine already has the select statement and the request from the SQL client, it doesn't actually have to do anything extra. It's already there. So that is actually a free lunch. The line number is always 0. The SQL statements are often very long, so you're a lot more likely to use the CST overflow file. There's a lot of, if you look at SQL code, you see things that are pages long. And so that's much more likely to exceed that 256 bytes than a 4GL query will. SQL statements also often have formatting. So line breaks, tabs, all those kinds of things will be in the SQL statement. So if you're writing some VST code to export what's going on there, you need to be aware that you have to look for multiple line entries, that it's not just a simple field with no formatting in it. So we have some benchmarks. Spent a little bit of time digging into it. With SQL clients, as you might guess, there is no discernible difference with or without CSC enabled. So you turn it on, turn it off, doesn't seem to matter to the SQL engine. I was kind of hoping, well, not really hoping, but I was kind of thinking that writing that CST file might have at least a noticeable impact, that there might be a couple of milliseconds difference, but in fact, there is not any difference to be found. Or it was so far down in the noise that you just couldn't measure it. Shared memory. So these are the 4GL clients. We have a table here. It's a bit of an eye chart for those of you in the back. Sorry, but you should have come up closer. What you see in the charts here is that a repeated find no lock, like we were talking about, has an impact of about 5 to 10%, depending on whether or not you do just the top of the stack or the full stack. So if you only do the top of the stack, the impact is about 5%. If you do the full stack, then you get about a 10% performance impact from it. That's when you repeat the same find statement over and over and over. When you have different find statements, so you got find first customer, find customer 3, find customer 12, but they're each individual lines of 4GL code, then that starts changing into a mixed find statement, and that's where you have a significant impact. Now your impact is on the 40% range. So you're really hurting throughput at that point. For each no lock, the impact is about 3% for top of stack. So it's very low impact for anything that's a query. Then I wanted to test whether or not having a very long path, which would cause the CSD file to be used, would have much of an impact. So I created a directory structure that was very deep, had long file names, filled up the stack that way, and made a much larger stack to go through. And the differences are noticeable. So you go from 5 and 10 to 12, and actually that's a 12% improvement in performance and a 25% hit. And then with the other cases, it's even worse. So making the path long does tend to make it worse. Now these guys that were positive are really weird. I don't know why it got better. But I ran the tests over and over and over, and I kept having that pattern of actually improving performance with long, deep paths. It makes no sense at all. Yes?
With the prefetch query, were you using the prefetch parameters?
So Rob's asking if with the for each no lock, was I using the prefetch parameters to support that? Since these tests were actually run in OpenEdge 12, those parameters are on by default, so the answer is yes. I did, I don't know if can't remember if I have a slide about that, but I did actually run the tests on 10, 11, and 12, and the results are roughly equivalent across all versions. There's no major difference in any of the versions. Yeah. So for remote clients, so those were self-service clients. Remote clients, the impacts were fairly similar in terms of the mixed find is once again where we have the biggest impact. It's a 40% kind of an impact, 40 to 50%. For each is not really all that much of an impact. And prefetch numrex, kind of to Rob's question, if you do increase it, will have an impact on the for eaches because you're packing more records into each of those queries. So the change in the statement happens less frequently. The information has to go back and forth to the server less often. So why are mixed finds so bad? Remember, a mixed find is when it's two very different statements in the 4GL. So you're not repeating the same statement over and over. You're going from one find statement to a different find statement. So you might be doing find order line, something like that. That will cause a change. But if you keep repeating the same one, then there is no change. So when you have CSC enabled in a client-server scenario, what happens is you get two additional network messages. So if you think about what progress does in client-server, when data has to go back and forth, there's a request, there's a response, and then there's a release of the cursor for a find. And we're adding two messages here. One is saying, well, actually, I didn't actually look at the network message, but I think it's saying, tell me what statement this is, and the other one is saying, it's this statement. So you have these two additional messages, which basically doubles the number of messages for find statements. So it's not really much of a surprise that your throughput is cut in half, right? Doing twice as much work, your throughput is going to suffer. The other thing that happens is that the user latch gets locked. So you have a little bit of latch contention, a little bit of latch activity going on there. Relative to the network activity, that's relatively small, but it is an impact. And without a large result set, because you're only getting one record back, So you can't take the latency that you're getting from those additional messages and quote unquote amortize it over a large result set. So your throughput suffers a lot more because the impact of the latency only has one record to feel it. And one way to think of it is that the behavior of find statements is really a proxy for a lot of bad code. So you'll see the same sort of behavior if you have a for each share lock or a for each exclusive lock. Anything that is not a for each no lock or a related statement like the dynamic versions of for each is going to have this kind of behavior. So if you have crappy code that doesn't pay attention to locking and you have share locks all over the place, the client statement cache is going to bring that out in spades. So you don't want to use it in an environment where your code is really bad. So in spite of my jokes about bad code, most of you do not have code that's that bad. So to recap, the impact of client statement cache for SQL clients, there's no discernible impact. Just couldn't find anything pro or con for SQL clients. For shared memory, the impact was pretty small. Yes, there is some impact, but it's not that big, especially for the for eaches. And if you think about what you do with a find statement, you're not doing tens of thousands of record fetches with finds in a short period of time. You're doing a couple of finds, and then you're doing some work, or you're going out and you're putting together a more structured query. So, a couple of finds here and there. Yeah, there's a lot of them, but the performance impact isn't necessarily that bad. Nonetheless, if you do have a lot of find statements, it might be a severe impact. So one of the possible mitigations there is to move that find code to use temp tables instead. Because also, if you think about it, what are you doing with those little finds? In a lot of cases, not all, but a lot of cases, what you're doing is you're looking up read-only control data. So you have some control tables in your database which are helping you to figure out what company number is this and what's the parameterization for such and such a feature. And you hit those tables over and over and over, but you never write to them. You're just reading from them. So if you move those tables into temp tables on the client side and only refresh them periodically, you can eliminate an awful lot of client-server traffic and improve your performance and not suffer so much from anything from the client statement cache. So here are some enhancement requests. If you go to or openedge.ideas.aha.io, we've got 2, 4, 6 things that you could vote for that would make the client statement cache better. Including things like, hey, shouldn't we be able to update the replication targets? Wouldn't that be nice? Having some DB startup parameters, adding a VST field to enable all, or at least see what the status of are all future clients going to have CSC on. You can increase the threshold for the in-memory cache. 256 bytes is really trivial. Today, 1K would be cool. 4K would be even better. Reduce or eliminate the user latching, and try to do something about the number of messages going back and forth in the client-server protocol. That would be great if they could consolidate those somehow. Okay. Now, there's one more feature. So you may have noticed that I said a couple of times that this only applies to database statements. And that's kind of a problem for some people because not everything is the database. You have 4GL code too, and sometimes you have 4GL code that does slow things. So there's another feature called ProGetStack. And what ProGetStack is, it was also introduced with 10.1c. Well, it wasn't introduced with 10.1c. Variations of it existed as far back as Mike Fergal here. I think they existed as far back as version 8, but they were inconsistent. And sometimes there would be a release that didn't support the ProTrace feature. It became permanently available in 10.1c. And what it does is it allows you to ask for a protrace from any running process, any running 4GL process. So you use progetStack, you give the process ID, and you get a protrace.pid in the working directory. And that will tell you the same information that the CSC tells you, but without the restriction that it's only the database statements. So if you're in a loop calculating the value of pi, it will tell you that you're on the line that is doing some exponentiation or something. And the output looks kind of like this. If you've never looked at a protrace, you get some great information. You get the command line arguments, you get the startup parameters, you get all this information here about the stack dump from progress. And then you get the ABL stack trace. So it tells you what the top line of the stack was, what line number you're on, just like it did in the client statement cache stuff. And it gives you a list of any persistent procedures or classes that you might have open, what your pro path was, and so on and so forth. Great information for debugging. So there are some differences between CSC and progetStack. So CSC is centralized. It's in the database. So as a DBA, you can enable CSC. You don't need to have any special privileges beyond whatever it takes to be a DBA. You don't necessarily have to be root. You don't necessarily have to be an administrator on a Windows machine. You might have to be. That will depend on how you were set up, but it's not a requirement. You can enable CSC, and then you have to wait for some sort of a database statement. So CSC never looks backwards. It's always looking forward. And then there might be some network traffic, so that's kind of a downside. progetStack has some pros and cons too. So progetStack does not work with PAS-OE. Multi-threading is a bit of a problem there. It reports whatever is running right now. That's great. But it does require local access. So you have to have access to whatever machine it is that Progress is running on, which if you're in a client-server environment can be problematic. You may not have access to the end user's PC. You have access to the database server, but you don't have access to all those client systems. And you would need administrator privilege. So you would need to be able to log in as admin to run progetStack. And it appends the output to a local file, which means that now you've got to go collect all those files from all the various machines that they might be on. And that's kind of inconvenient compared to just being able to sit on the database server, launch a query against the database, go into Promon, see what's happening. So you have a lot more chasing around after things if you're using progetStack. Whoops. So, any questions? Yes? Copy. Oh, so it'll tell if you have done if you've gone into the tram lines and typed in some ad hoc query, then you'll have a .ped file. Yeah. No. No, those will be in your local directory, but they're temporary. Ah, okay. Yeah. So you're talking about the progress debug, the PDB file.
Yeah, the PDB. Yeah.
Okay. Yeah, that's different.
But then if not, you won't get those beautiful line numbers and method names, I think, in Windows. You get APO stack, POC stack might be messed up. Yes.
Right. You would get the usual.
You still get the ABL call stack.
Yeah.
Okay, you get the ABL, but
Yeah, but the C stack's only for Libor. The rest of us want the 4GL stack. Okay, good. James. That's a fairly recent feature. So James is. Yeah, well, for me that's recent. So in 11.7 and above, the log file, the database log file, will tell you where to find the proget stack, which is nice because previously you had to hunt around for it. You never really knew where the user was dumping it, and you would end up searching all over Tarnation to find it. Rob, do you have a?
Just an observation, it's kind of shown in your display here that not only do you get the procedure name and line number, you also get, if you were in an internal procedure or a function or method call, you get the name of that module as well.
So if you guys didn't hear that, he's pointing out that in the 4GL stack, you would get not just the .p or the .w, but if you had an internal procedure or a class method, you would get those bits of information as well. Other questions? Yes?
For ProGet stack, you talked about administrator privilege. You need to be admin if you're not the user you're signaling, but if you are that user, you can issue the ProGet stack command.
Okay, so admin privilege, you need administrator privilege if you are not the same user that you're trying to get the stack from. And that's true, but I usually assume I am not that user. Yeah, there are cases where, yeah, you can get your own ProGet stack, but if you need somebody else's, you need to have administrator or root permissions to do that.
But if you're calling them on the phone, you could say, hey, type this command, go get this file, and they'll be able to do it. Because presumably...
And why does an end user have shell access?
on their own machine. They're a remote user.
Why does an end user have shell access?
Because they're on Windows?
Okay. Bad idea.
Didn't say it wasn't.
So you make it easier than that. You just provide them with a big button on the screen which says get this stuff, email it to support, and then they don't even need to do anything.
An excellent idea. Did somebody in the back have a question? I thought I saw something. Okay. Oh, yes. There are some things going on with PASOE. There is, I forget exactly what you do, but you can get a JSON file that has similar sorts of information in it. Libor, do you know what I'm talking about?
Yeah, you need to query the password itself and call some REST APIs to get it.
So that would be the OS metrics API, not OS metrics, the OE manager. Yeah, you can get it from there. Anybody else? Going once, going twice. All right, thank you.